Okay, number 11. We're asked the question, is f of x defined below continuous at x equals 5? So I'm not trying to be funny, but what I'm expecting here is either yes or no. We just need to figure out which one it is. And along the way, we're going to explain how we arrived at yes or no in terms of the three parts of our definition of continuity. So I'm going to run through those three parts, and then we'll see if we get a continuous function or a discontinuous function, a yes or a no. All right, so step one in our definition of continuity asks the question, does f of x exist? In other words, does f of 5 exist? Do we get an answer for f of 5? Well, using this piecewise function, I'm going to use the top expression when I plug 5 into this function. If I plug 6 in, I'd use the bottom, but I'm plugging 5 in, so I use the top. And I can plug 5 into x and get the answer of 5. So that is true. F of 5 does exist. The second part really has its own two parts. It's asking us, what's the limit as x approaches 5 of f of x? In other words, does the limit exist? To check that, I have to go from the left and the right. When I do the left, when I go from the left side, I have to use the top expression, and we already know that answer's 5. When I do the right, I have to use the bottom expression. So I'm going to do 5 minus 4 squared minus 2. That is 1 minus 2, which is negative 1. So the limit doesn't even exist. These two are different. That is a sad face. So we failed right here, and therefore f of x is not continuous at x equals 5. So I would say something like, no, f of x is not continuous, or you could say discontinuous at x equals 5. And this math that we did explains why we said no. If you did the math and just wrote no, I'd be able to figure out what you're talking about. The bottom line is the 5 and the negative 1 are different. So there's a jump here, and this function is not continuous. Okay, that was number 11. We just have two more to do, and then we're done.